Hi, welcome back to Missing Chemistry. Today's lesson is Lewis Structures, lesson number 5. We're going to look at a couple examples in this lesson here. So let's go ahead and start with the first one. It's oxygen diiodide. That's an interesting one. We haven't done that one before, so let's try it. OI2. Okay. So first of all, oxygen is in group 16. You know that it brings 6 valence electrons to the table. Iodine is in group 17, so it brings 7 valence electrons to the table. So let's go ahead and calculate the number of valence electrons. We got one oxygen with 6 valence electrons, and we got 2 of those with 7 valence electrons. This gives me 14 valence electrons and 6 valence electrons, which is 20 valence electrons. Now when you look at this, so that what we're going to do is we're going to have to draw a structure that has 20 valence electrons. So what we're going to do is we'll start this off with O, put an I here, put an I there. And we're going to connect the I's first. And then that's 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Now when we look at that, is that the right structure? Let's see here. This is A, that's X, that's X. This is E1. This would be E2. So this would be an AX to E2. So you know that structure is bent. And that's not a bent structure. So we're going to have to redraw it to look something like this. Kind of like the water H2O1, okay? And now we're make that structure look like that. And that structure looks pretty darn good. Okay, now we got this. Let's see here. So we look at our total number of electrons, or 20 electrons are showing. Okay, so let's try our formal charge for oxygen to see if it's good. So we're going to go, remember that it's valence electrons minus non-bonding electrons minus bonding electron pairs. So for the oxygen, comes in with 6 valence electrons, 4 non-bonding electrons, and of course 2 bonding pairs. And that gives me a total of 0. So that looks good. The formal charge for just one of the iodines, we don't have to do them both, 7 valence electrons it came in with, 6 non-bonding minus 1 bonding pair, gives me 0. So that looks good. Okay, so now let's look at the hybridization for the oxygen. And let's see here. Oxygen's got 1, 2, 3, 4. So that would be sp3. And I's hybridization would be 1, 2, 3, and then of course that thing again, 4. So that would also be sp3. So that structure looks good. Okay, so now let's look at another compound. And this one we're going to look at, let's see here. How about, let's try Br2, okay? Let's look at Br2. So we're going to clear all the drawings here. And I guess we'll go ahead. No, I tell you what. Yeah, let's do Br2. So let's see here. Br2. So that's diatomic. So Br is in group 17. So each Br brings 7 valence electrons. Okay, so we go Br is 2 times 7 valence electrons. Gives me a total of 14 valence electrons. So we need a total of 14 valence electrons. All right, so we're going to draw out Br. Since they're the same, they're going to be both coinciding. 2, 4, 6, 8, 10, 12, 14. And note that the structure is just an AX structure, which is linear. Bond angles are 180 degrees. And let's see, let's try our hybridization for Br. It's going to be 1, 2, 3, 4. So it's going to be sp3 for both the Brs. Okay, well, let's look at another one here. Let's look at hydrochloric acid, HCl. In this case, hydrogen's in group 1, so it brings in 1 valence electron. Chlorine is in group 17, and it brings in 7 valence electrons. Okay, so now we're going to go ahead and do the instructions. So it's 1 times 1 electron here, and chlorine is 1 times 7 electrons. This gives me 7 electrons plus 1 electron, gives me a total of 8 valence electrons. So we'll go up here, put this together. We're going to connect H and Cl. Hydrogen satisfied. So it's 2, 4, 6, 8. And this structure is called an AX structure. It's also linear, 180-degree angle. And let's see what the hydrogen's hybridization would be. It would simply be S. And the Br, let's see, not Br, I mean Cl. Look at the one above, I apologize. Okay, let's look at the Cl hybridization. So Cl would be 1, 2, 3, 4, be sp3. Well, looks good. And of course we could do formal charge here if we really wanted to. Let's try that real quickly just for fun. So the formal charge of hydrogen, remember it's valence electrons minus non-bonding electrons minus bonding electron pairs. So hydrogen came in with 1 minus 0 minus 1 is 0. So that's good. Let's do the formal charge for chlorine just to make sure. Chlorine came in with 7 valence electrons, 6 non-bonding minus 1, 0, and that's also good. So this is the best possible structure. And you guys have an awesome day. We look forward to seeing you again at Moose in Chemistry.